So I'm going to introduce myself. My name is Muhammad Ali Khalidi, and my official title is Presidential Professor of Philosophy at City University of New York Graduate Center. That's a bit of a mouthful, where I moved recently from York University in Toronto. And I am working on a book for the Cambridge Elements series entitled Natural Kinds. It's going to be under the sort of philosophy of science rubric. So that's who I am.
Good to see you. I'm Tuomas Tahko. I'm a professor of Metaphysics of Science at University of Bristol, before which I was in Helsinki for several years. I'm also an author of the Cambridge Elements in Philosophy of Science series. I've authored a book called Unity of Science, which is very closely related to a project that I'm running here in Bristol, funded by the European Research Council under the Horizon 2020 Research and Innovation Program. That's grant agreement number 771509. So the project that I'm running here is on the metaphysical unity of science, and that's the topic that we've agreed to discuss today. Unity of science and natural kinds, which are both of our book titles, and indeed a topic that we've discussed before. And I'm looking forward to having this chance to discuss this with you further. I don't think that we need to give any detailed outlines of the contents of the book or the written material here, but we could start by talking about just the history of unity of science very briefly, I think. And the history goes, of course, to Paul Oppenheim and Hilary Putnam, who put forward this now a classic and I suppose a notorious picture about the unity of science, which presents us with something I've pictured as a pyramid before, a hierarchical structure that connects all the sciences from fundamental physics to all the way to social sciences, I suppose, and psychology, via a single relation. I think they call it microstructure, but composition seems to be what they have in mind. And I think from our previous discussions, we both agree, as I think, would you say maybe virtually everyone agrees now that picture is inaccurate, and something more complicated is probably closer to the truth?
Well, I don't know if everyone agrees, but I do think there's a consensus emerging that there's something seriously wrong with that picture. But I think there's no harm in maybe going over a little bit what exactly is wrong, because I think there are several things wrong, and maybe they're not always kept completely separate. You mentioned two things which I think are keys to identifying what's wrong with the picture. I mean, the pyramid picture with, the fundamental physics at the bottom, and then chemistry on the second floor, and biology on the third floor, all the way to, I don't know, sociology or economics at the top of the pyramid. I mean, one very simple thing that's wrong with it is there's something a bit misleading about the pyramid idea, because at best it should be something more like an inverted pyramid. Because if anything, the entities that we posit at the lower levels are much fewer than the ones that we posit at the higher levels. So, the higher levels in sociology or economics or whatever you think the higher level sciences are populated with a much broader array. Whereas if you look at the theory that is the sort of paradigm in fundamental physics nowadays, the standard model, well, there's a certain limited number of quarks, leptons, and bosons that are posited. And so anyway, that's I think a very simple thing that's wrong with it. But the other thing, I think another thing that's wrong with it is the other thing that you mentioned, which is the idea that there's a kind of compositional relation between the layers. So everything in chemistry is composed of things in physics, and then everything in biology is composed of things in chemistry, and so on. And while that might hold for the entities, I don't think it holds for the properties. I mean, properties are not literally composed of, the properties at the lower level. So it's not as though the main entities posited in economics are in some sense composed of fundamental particles. But the properties of economics, like economic value or the kinds like inflation or whatever, are not actually literally made up of the properties like charge and mass and spin, right?
Mm-hmm.
So I think that's a second thing that's wrong with it. And I think there are other things as well. I don't know if I should go on, but what do you think, Tuomas? What's your take on these issues?
Yeah, I mean, as I say, I think that we do agree on the basic problem of the picture, and you've very nicely pointed out two main issues with it. I mean, if I just pick up the ball there and carry on, the third issue is, I guess, that we surely don't have a single relation that connects all of these different sciences, whatever shape that pyramid or whichever way that pyramid stands. So if we just focus on composition, well, as you already said, even if there is a sense in which the higher level entities are composed of the lower level entities, that is surely not the end of the story. So there's going to be relations of some type of dependence in broadly speaking, dependence relations that go not only between the levels, if there are levels. I mean, the level talk itself is problematic here, maybe, but if we think of these things as levels, then at least in some cases we can find dependence relations within the same level that are sometimes more important, perhaps even than those compositional levels that we see as cross-cutting between the levels. Now, I don't know, it might be good to give examples here, but something that I like to think about is a chemical molecule and the interaction that it has with its environment, maybe molecules of the same kind or a different kind. So those would seem to be interactions or dependencies in the same level, like the chemical level, as it were. But to understand truly what a chemical molecule is, we would have to take those dependencies into account, and we can't give a full story, as it were, about what it is to be a given molecule, say a water molecule, but just looking at the composition of the water molecule.
Yeah, and I think, I mean, another thing maybe one should point out, I mean, even that scale, I mean, if you think of the relationship between levels as in terms of size or scale, that's not quite apt, because we also think of some of the more fundamental sciences as they also happen to operate at very large spatial dimensions. So think of cosmology. Where would you fit cosmology in this kind of simplistic pyramidal view? Well, in some sense, it should be at the top rung because it's about the very large. But in maybe a more important sense, it should be at the more fundamental level because it's dealing with some of the fundamental forces and types of things in the universe. So that's yet another, I think, problem with it. And a further problem, and this is maybe related to all of these, is there isn't, I mean, it's related to what you said about cross-cutting, I think. There isn't a single kind of ordering relationship, because if you think of something like, economics or some of the social sciences, well, of course, it depends on psychology to some extent. The way human beings behave in the marketplace depends to some extent on their cognitive makeup. But of course, there are also all kinds of facts in economics which depend directly on things like meteorology, so the weather affects the price of crops and things like that. So there's a kind of skipping between levels. There's a sense of it. I mean, I prefer to think about it more in terms of causal processes, which are sometimes kind of orthogonal to each other. So yeah, very often in science, we isolate a domain of interest based on the causal interactions between the entities. And that will often, that kind of causal field or causal domain will often be orthogonal to other causal domains. And so there's a lot of cutting across of these different domains. So rather than this kind of neat hierarchical picture, like a pyramid or the stories in a building, I think we have this kind of interpenetration of different kind of causal domains, all of which involve these, sometimes fairly self-contained causal processes, which, however, also interact with things in different domains. So I think by now the pyramid is really shot to bits. I'm not sure that we can salvage anything. I mean, it would be nice to come up with a different image. I don't know what the appropriate image is. Maybe it's too complex to have a very, very arresting or very kind of attractive picture of it. But it would be nice to replace it. Sometimes I think some of these very postmodernist architectural structures, the deconstruction movement in architecture, where you have these stories intercutting each other and different floors of buildings kind of merging together or something like that, maybe.
Floor 13 and a half.
Sorry?
Floor 13 and a half.
Yeah, that's floor 13 and a half, exactly, yeah.
Yeah, that's a nice image. Another one that I'm playing around with, although I'm not sure if that works either very well, is some sort of a tree structure or root structure rather of a tree, where these roots can kind of go upwards and downwards, depending where the nutrition is to be found.
Right, yeah.
Wouldn't want to try to draw that though.
Yeah, Bill Wimsatt has some interesting diagrams. I don't know if you know Bill Wimsatt's work, but in his collection of articles, whose title escapes me for the moment, he's got some interesting diagrams where he tries to, I think, advance a somewhat alternative picture of how the sciences relate to each other and what the unity of science consists in.
Yeah, well, it's certainly going to be an improvement on the Oppenheim and Putnam picture. We can agree on that. But so can I ask you, how do you see that this speaks to the issue which Oppenheim and Putnam were interested in originally, which is reductionism, of course. Do you think that this sort of automatically falsifies that type of picture that they were looking for, or should we just understand reductionism differently? I mean, to give this context, my own interest is in, as you'll know, to distinguish between what we might call semantic and ontological reductionism, and I think that part of the problem in the literature about unity of science is that these two get conflated. So ontological reduction would then be the type of view where well, I'd like to say a weak view about reduction in some sense, because it means that we can retain higher level talk, higher level concepts and predicates, whereas we can still acknowledge that there's going to be something like, say, a composition relation that enables us to explain how those higher level things are composed of lower level things.
Yeah, I mean, no, I think that's a very useful distinction between ontological reduction, maybe, and epistemic reduction. But I also think, I mean, I think you're right to say people often confuse them, but I also think we've got maybe a very deeply held prejudice in thinking that because things are ontologically unified, yes, there is a sense in which everything is just concatenations of fundamental particles. I think it's hard for the human mind to grasp how, if that's the case, why shouldn't it be the case that all the properties and the kinds and the laws can also be understood in terms of the fundamental kinds and properties and laws, so that we can, in principle at least, spell everything out in terms of the properties and kinds and laws of fundamental physics. And I do think it's a sort of a perplexing thing. We have this tendency to think that, well, if everything is compositionally somehow unified, or if ultimately, if you throw out the elementary particles from the universe, you're going to throw out everything else. How is it that we can't explain everything in terms of the elementary particles? And I guess, I mean, I don't think there's a single answer to that question. I mean, sometimes it's useful just to keep in mind that the things could have turned out differently. We could have lived in a universe where all there were elementary particles. You know, because of some of the fundamental constants, they never actually came together to form atoms and molecules. And even if they did, you know, we could also live in a universe where all you had were atoms and molecules, and maybe life didn't come about, and so on. Mm-hmm. So it's kind of worth keeping in mind that, yeah, we happen to live in a universe where when you put things can come together and combine and produce these other more complex things. And I think the other thing maybe to bear in mind, and this is maybe a bit more, this is, you know, a bit more debatable or worth thinking about a bit, is conceivably, it seems to me, we could live in a universe where when things come together, they just create larger versions of themselves, as it were, right? Now, it's hard to think about in our universe, but it could be that when protons come together, they form large protons, or, you know, when electrons come together, all they form is large electrons, which just sort of replicate the same properties that they have, but larger. Now, our universe doesn't behave that way. You know, when protons and neutrons come together, they form atomic nuclei. And when they get together with electrons, they form these things called atoms, and so on. So it's kind of, I mean, once one starts thinking in those terms, I think one realizes that it seems to be a sort of unusual fundamental property of this universe that we live in, that the things that happen when you combine the basic things are qualitatively different than those basic things themselves. You know, it's not a kind of universe where you have these Lego bricks and you put them together and you create one large Lego brick, right? You're creating these things that look and act and have properties that are quite different. So I don't know, maybe that's part of, you know, a partial antidote to this puzzle of, hey, how is it that you can't explain everything in terms of fundamental particles, you know?
Good, that's a nice take. So the motivating question here is, of course, photos. Why is there something other than physics? And you've just provided a very elaborate answer to that. I would say so.
I mean, I've provided a sort of image for how things maybe could have been otherwise, but yeah. I do think it's a very good question. Why is there something other than physics? And I think part of why it stymies us is I'm not sure there's a single answer. I think the answer has to do with all kinds of different effects that occur in our universe when we put things together to create complex things. Yeah. And one of the things, I mean, the answer that's, I think, given by Fodor is, you know, to put it in a nutshell, multiple realization, right? Yeah. I mean, I think that's a good answer, but I'm not sure that that's a complete answer to the question. I think multiple realization holds part of the secret to why things are so different at the macro levels than they are at the micro levels. But I think there's also other things, like, you know, the simple fact that there are some properties that are just inapplicable at the lower. I mean, you know, something like mass. Yes, of course, you get masses together, you add them up, you create a large mass. But if you think of something like viscosity in fluid dynamics, you know, you can't talk about the viscosity of a single particle, right? Viscosity only comes about when you've got lots of things moving and jostling together. And they have different ways of moving and jostling together, depending, of course, partly on the properties of the smaller things, but also depending on the way those things interact with each other and so on.
Yeah, I do agree with all of this, but it does sound to me that the answer you was sort of gesturing towards here is that what we get in this universe, at least when things come together, is novelty, or something like, I mean, maybe you didn't mean to suggest this, but the word emergence comes to mind, and of course that is sometimes thought to be what multiple realizability points toward as well, although this is controversial territory, as you'll know. Now, I mean, you said that there's no single answer, so I take that. But if there were to be a single answer, then it sounds like maybe novelty could be suggested there. Now, my own worry here is that even though I think that there may be genuine multiple realizability, it's often conceived from two different extremes. So either it's a fairly trivial matter. So think about the different ways to realize the property of hardness. You know, diamonds are hard, and rocks are hard, and metal is hard. But these are all different kinds of hardness in some ways. We've got different scales of hardness as well. And that doesn't seem to be an interesting kind of novelty to me, because we can reduce, if you like, all these different cases of hardness to you know, various molecular structures that give some sort of stability. Now, the other extreme, of course, would be to say that, well, multiple realizability is very, very rare, and those cases don't really count as multiply realizable at all. I'm thinking maybe the line that Polgar and Shapiro take in their recent book on this, but they do nevertheless think that there are some cases, and those I suppose would be the interesting ones. Now, I guess my view is that there there is multiple realizability, but that doesn't necessarily prevent reduction in the sense that I'm talking about it in this ontological sense of reduction. So often we find that what is being realized can come about in different ways, but there's going to be subtle differences. Like in the hardness case, we can definitely see that, but that's maybe a too easy example. What do you think?
I mean, hardness by itself doesn't seem to be a very, I mean, it's a property, but it's not clear, you know, how whether there's interesting generalizations to be made. I mean, I think once you start talking about a particular kind of hardness, or once you start talking about how hardness is sort of put to work in doing other things, or is having certain kinds of regular effects in some domain, and then you know, playing the same role across different domains, regardless of what the underlying components of that hardness or the underlying determinants of that hardness is, that's when you start getting, I think, genuine sort of multiple realization. I mean, so some philosophers have been generally skeptical of multiple realization and have said, well, look, ultimately, they can all be explained in terms of other things. We'll allow that maybe once you have, say, design, either artificial design or design in the case of natural selection, well, maybe then genuinely new things, genuinely novel things can come about. So, I mean, to take a simple example, take a thermostat. Now, thermostats are clearly multiply realizable, and some of them use the bimetallic strips, others use some sophisticated electronic circuitry, and yet they all sort of have the same function, they play the same role, and you can sort of think of, there's certain kinds of generalizations you can make about thermostats. And some people have said, well, yes, they're okay, you might get genuine novelty. But I guess my answer to that is, well, but it's not that humans who have designed these thermostats have created this novelty out of thin air. It's because we exploit these regularities in the world that we're able to make thermostats, all of which share certain properties and about which certain generalizations can be made. And I want to say the same thing about biological structures, too. Natural selection exploits regularities in nature, right? And so the fact that you have eyes that, different types of creatures have different types of eyes, all of which enable them to perform the same functions. And you can make generalizations about, what creatures with eyes can do that creatures without eyes cannot do, and so on. But all that, of course, Mother Nature is exploiting pre-existing properties in the world. And so I think that is a way of sort of undermining this idea that, well, the only place that you have genuine novelty is in, say, naturally selected structures and mechanisms, or in artificially designed structures and mechanisms. Well, artificially designed and naturally selected structures and mechanisms are just exploiting these properties that are themselves multiply realized. So, I mean, I think, the hardness example maybe is not terribly convincing because it's not clear what follows from the hardness. But I think that there are all kinds of cases, you even take something like viscosity, two substances can have the same viscosity, even though they have very different underlying structures, and they might behave the very same way at the macro level, despite the fact that there's really no commonality in terms of their chemical bonds or in terms of, what sort of molecular structure they have and so on. So, yeah, I do think there's genuine novelty, and I do think part of the novelty comes from this feature of our universe, which is that, when things combine together, they can realize similar properties, even though their underlying micro properties could be very, very different. I mean, I think, another thing to say here, apart from multiple realizability, there's other things that distinguish the large from the small. I mean, one is that even when it comes to properties that we think of as being additive, they aren't simply additive. So in general, when you combine two volumes together, V1 and V2, you don't get just V1 plus V2. You often get, because of the way, if there are two different types of substance, the molecules fit together in a certain way, you get a V3 that's not just a simple sum of V1 and V2. So even when it comes to something like volume or mass, the additivity doesn't hold universally. So I think I guess to sum up, I think there are lots of reasons why there's novelty when you start combining things. And yeah, I have no problem in saying that there's novelty. Does that make me an emergentist? I guess it depends what you mean by emergence and what you mean by novelty. But I think part of the reason why it's so puzzling is because there isn't a single reason for why you get novelty, I guess.
Yeah, good. I mean, I mentioned the word novelty partly to keep things a bit more neutral in a way, so that we don't enter all the complications regarding emergence and different interpretations of that. But of course, the same applies to novelty. You're right about that. Well, so here's one question which we've touched a little bit already, and maybe this can be, if not a source of novelty, then at least something that can be used to track it. You mentioned empirical generalizations, and we've mentioned properties and causation, and implicitly at least laws of nature. And of course, I know that in your work, and indeed in my own, this all comes connected to natural kinds, which is topic of your own element. So how do you see these things playing together, these different notions or different aspects of philosophy of science in a way? So do you think that the way to track novelty, way to track where the genuine high level kinds might be, and hence to give some hint about unity of science, if such exists, do you think that is driven by causation, laws of nature, empirical generalizations, or some combination of these things?
Yeah, I mean, I find it hard to unravel these very basic metaphysical posits. I mean, I think kinds and properties are very closely related. I think that kinds are, clusters of causally connected properties. And I think that when properties are causally connected in that way, we have either laws or empirical generalizations. I mean, I think if you think of laws as being sort of truly exceptional laws, I don't think we have very many of those. At best, we have maybe a handful. And so of course, when you have empirical generalizations, they generally describe causal relationships. So these basic metaphysical posits of kinds, properties, causal powers, and natural laws or empirical generalizations are very sort of closely intertwined. And I'm not sure that, any is more sort of fundamental or basic than the other. I mean, I think maybe causality is sort of at the heart of it. And I don't really have any original things to say about what causality is, or whether it's one thing or many. I worry a little bit about whether causality is one thing or many. And if causality is many, then yeah, there is a sort of multiplicity at the heart of this whole picture. And I know you find this a little unsatisfying, and you want to sort of find the sort of metaphysical unity that underlies all this. And I'm not sure that I have anything more to say about that. But maybe you should tell me why you think just sort of saying, well, causality is rock bottom, and I don't really know what more to say about what's behind causality or something. Maybe you should say why you find that unsatisfying or not completely satisfactory answer.
That's a reasonable enough request. Yeah. Well, just to mention one thing, to set it aside, of course, I do worry a little bit about, just in the literature surrounding causation, about the classic arguments against fundamental causation, or the reality of causation at the fundamental level. And I suppose that I'm a little bit more persuaded by the, if not an anti-realist, then at least a sort of perspectivalist or some other approach to causation, which would mean that it can't really do the metaphysical work in unifying the properties of natural kinds, for instance, that you might want, at least not at the fundamental level. But I don't really want to enter into that debate about causation. I'm sort of willing to grant the possibility that there is a solution to these puzzles, but there's still going to be questions to be asked about, especially those fundamental cases. I guess that's how I'm often trying to approach this question, is that, well, if we can find convincing, plausible cases of genuine natural kinds, then we better find them at the level of physics, fundamental or near fundamental physics, and perhaps chemistry. But as you know, one question that is problematic, at least, or puzzling for various approaches that take causal mechanisms to be the unifying source of the properties of natural kinds, are cases like, say, electron, where the mass and the charge and the spin of the electron, which are presumably its defining properties, how do they come together? How are they held together? Now, in the case of biological species, we know various approaches to the homeostatic property cluster theory seem to provide a very nice and quite widely accepted answer to the unification of those properties of the organism. But I think you have criticized the sort of general applicability of the HPC theory, and I'm sympathetic to some of those points. But then it doesn't seem to me that we have much more than some version of the HPC theory. It could be a more sophisticated version, of course, but it doesn't seem to me that there's much more on offer that we can say about those lower level fundamental kinds. So what brings those properties together? Now, this sort of brings us to questions about whether it's just a brute fact that these properties are unified, and I do find that a little bit unsatisfying. So I want to say that, well, at least we can give a metaphysical story about what is the general unifying principle behind natural kinds, and I would not postulate causation as that principle, but I would take the natural kinds themselves, which I think are substantial universals. I would take natural kinds themselves to do the unifying work, in a sense. Now, that's just a general principle, a metaphysical principle, and you have to spell out the details. Often these will be empirical details, and in some cases, I think that story about causation can be the right story to tell. But it sort of leaves the door open to a plurality of different kinds of stories, depending on what kind we have in question. Now, I realize that's not a complete answer either, but it suggests that we can give a unified answer about the metaphysical basis of unity for natural kinds, or the properties of natural kinds, and then work out the details together with the empirical sciences, if you like.
Yeah, I mean, I think that's an important challenge. I guess I don't fully understand, what it is to say that the natural kind is what unifies the properties. I do think, one thing we are in agreement about, I think, is that causal mechanisms are not always the right way of thinking about what unifies the properties. And I do think that mechanism has been overused in a lot of contemporary philosophy. So basically, causal mechanism, at least in the work of some people, just is pretty much synonymous with causation. And I think that actually strips mechanisms of what's distinctive. I think mechanisms are, certain kinds of structures that have parts and components that are organized in a certain way and so on. And I don't think that's an apt description of everything causal that happens in the world. Maybe a cell is a mechanism, maybe a thermostat is a mechanism, paradigmatically a thermostat is a mechanism maybe, but I'm not sure that the nucleus of an atom is a mechanism and so on. So I think we're right about that. And incidentally, I think Richard Boyd himself didn't think, at least in conversation, shortly before he passed away, it was me and a few other people talking to him one day at the PSA, Philosophy of Science Association conference, and he said, well, you know, who would ever offer a single account of what a natural kind is? Clearly, you know, there is no single account of what a natural kind is. So at least later on, he didn't seem to think that his homeostatic property cluster account, where there's a mechanism that keeps the properties of the kind in homeostasis, was a kind of unitary answer. And I shifted uneasily in my seat, because in a sense, I'm trying to offer a unitary answer, and the answer is causation. Although I also acknowledge that causation plays a different role in different kinds, in how the properties combine together. And of course, you're right to point out that the one glaring exception would seem to be the most fundamental particles, whose properties, whose basic properties don't seem to be held together using, or in a way that involves causation. So the spin, the mass, and the charge of the electron are not somehow, as far as we know, causally related. Now, I would want to say, I wouldn't want to rule out that inside the electron, we might find more fundamental entities that are holding those properties, or that are somehow accounting for why those properties are causally connected. And you might say, okay, but then what about those entities? And I'm not sure we should rule out the possibility that it's, as it were, elephants all the way down. I mean, some physicists and some philosophers have taken seriously this idea that, well, maybe, you know, inside the Russian doll of the electron, there's another Russian doll, and inside that one, there's yet another one, and so on. Now, when I've said this to some philosophers, they say, we think that that whole idea is incoherent. But I certainly wouldn't want to rule it out, because, you know, intuitively it doesn't seem right, or it just seems to sort of infinitely pass the buck. Who knows? Maybe that's the way our universe is structured. But you're also right to point out that, say, at the quantum level, and, you know, for certain kinds of relativistic considerations, causality seems maybe not to be fundamental. But you know, I still think that it's really what holds things together. And we also have a very, you know, we have very robust empirical ways of, say, distinguishing causation from correlation. And so it seems to me it's something that's sort of empirically tractable. And I don't mind basing, at least, you know, well, certainly basing kinds largely on causation. Now, you know, and maybe I can see why you know, someone might find that sort of metaphysically unsatisfactory, but I'm not sure that saying that the kinds themselves unify the properties really supply me with a metaphysical picture that I can really sink my teeth into anyway.
Good. There's a lot of interesting points that I'd like to touch on. For what it's worth, I think on Boyd, you're right. It didn't seem that to me that he ever wanted his account to be generalizable necessarily, although many people have tried since to generalize it. And for what it's worth, you are talking to one of those philosophers who take infinite descent seriously, the possibility of infinite descent at least seriously. So I don't think that it's an incoherent suggestion. I mean, it obviously leaves some questions to be asked about how how you deal with infinite chains of dependence, grounding, fundamentality, which metaphysicians have been debating for a long time. But I do think that there are some promising suggestions in the literature on how this could be done. So you know, I'm sympathetic to the possibility of this. However, it might not be wise to make your account hostage to the possibility of infinite change of dependence that could emerge from this. I think this is what people find problematic about the view. So there's work to be done there. But you know, putting that aside, I guess we're touching on the key issues here. I was just hoping to clarify one issue. So when I say that the natural kinds unify the properties, I'm really talking about a very metaphysical, abstract picture, obviously. So I just want to make that clear. I don't think that the natural kind is doing any causal work there. As it were, the kind itself, being an Aristotelian immanent realist about universals, the kind itself is instantiated in the world, as it were. But if you think of the kind as a universal, it's not going to be causally participating in worldly actions, as it were. So I'm really talking about the abstract categorical structure of reality as I see it, and then we have to fill in the details largely with empirical considerations. So the advantage, albeit maybe a small advantage, but the advantage that I would claim to have in the cases of fundamental kinds, for instance, like electron, is that I can acknowledge that there can be different answers, non-causal answers, perhaps, to the unification of those properties of the electron, and I can be satisfied with that. So the sort of further question about how the properties are unified, it's an empirical question still, to an extent, but there might not be any kind of further causal process that we need to recognize for this. I mean, the way I see it is that the alternative is then that we just acknowledge that it's a brute fact, which is surely going to be a little bit unsatisfactory. But of course, the science could tell us all sorts of things, and I also wouldn't want to rule out the possibility that there could be a further causal reason in that particular case for the unification of the properties. If we find some substructure there. Okay, so that's one interesting aspect of this. But if I may suggest a further related topic on natural kinds, because I know you have views on this, and we discussed this before. So one reason, of course, that I'm pushing for a very robust realist view of natural kinds is that I think that there has to be a fact of the matter, a determinate fact as to whether something is a kind or not. And we've talked about this a little bit before, and I was hoping to hear your most recent views on this. So the possibility of borderline cases of natural kinds. So the examples we've talked about would be biological species. One that I've talked about a little bit is transuranic elements. Things that we might synthesize in our particle accelerators, but which might not naturally occur in the world. So it could be even that there are some transuranic elements that we would have, we have a good reason to think that there is a stable element there, but we just can't afford to synthesize it. It's too costly to launch the particle accelerator. And even if we did synthesize it in the end, it would be dependent on our actions, and it would have a very fleeting existence, maybe measured in milliseconds. Now, I think that even in these cases, there is a fact of the matter and a determinate answer whether something is a natural kind or not. And of course, I base the reality of the kind then to the existence of that kind universal that corresponds with the kind. But I think that you may take a differing view on some of these cases about whether there is a determinate fact of the matter.
Well, I mean, I do think there is a determinate fact of the matter. I also think that, say, in many of these special sciences, there are lots of kinds out there.
Mm-hmm.
You know, and I think it's possible that we've just scratched the surface in identifying some subset of them. Now, often those kinds are very closely related, or they're almost extensionally the same, although maybe intentionally they're different. So biological species is maybe a very good example, because at last count, there were something like 25 different species concepts, as they call them. So different ways of, you know, whether they occupy the same ecological niche, or whether they interbreed, or, you know, something like, and produce fertile offspring and so on. And for most intents and purposes, those demarcations are extensionally equivalent, with some interesting and notable exceptions. So I think there, it's not so much that it's indeterminate which kinds there are. It's more that there are all these different kinds out there, and we happen to single out some of them rather than the others. I mean, right. There's also a problem with species about where one species ends and another begins. So if you look at it over time, there might not be a sort of determinate cutoff as to where one species ends and another begins. Mm-hmm. So yeah, I would just now I don't know. Does that mean that kinds have vague boundaries? Yeah, maybe sometimes kinds have somewhat fuzzy boundaries. Yeah, I'm willing to live with that.
Yeah, I mean that's a fair point. We should distinguish between whether there's vagueness or some fuzziness regarding whether a given individual is a member of a given kind, and whether the kind itself could have vague boundaries.
Yeah, that's a good point, and that's something I think worth thinking about a little bit, how to make that distinction. Yeah.
Yeah, I'm trying to think what I should say about this in the interest of consistency with my other views, because it is a little bit tricky. I mean, on a traditional view, I suppose one would have to say that an individual is necessarily a member of a kind, but you might think that there's a possibility of kind change, you know, that a given individual can become a member of another kind, another biological kind, for instance. But you can find cases like this actually, or that look like cases like this, where an individual changes its kind membership, even in physics. So something like beta decay, where a particle becomes a different element. Now, in some of those cases, I'm inclined to say that there really isn't a kind change at all, but there's just one individual going out of existence, as it were, and another one coming into existence. But it's a bit trickier to uphold that answer, maybe in some of those biological cases where we can at least imagine quite easily a case of you know, a cat being transmuted into a dog.
Yeah, I mean, according to cladists, in fact, when speciation occurs, both species are different. And so you might have no intrinsic change in a particular organism. And just by virtue of the fact that there has been speciation, that organism now automatically belongs to a different kind. Now you can reject the Cladist view on this, and as you said, with beta decay, where a neutron decays into a proton, electron, and an antineutrino, there you could say, well, the neutron has gone out of existence, and these three new particles have come into existence. That's not the way it's usually described in physics. I mean, yeah, maybe that would make your metaphysics neater, but yeah, that's to deny essentialism about kind membership. Yeah, and I talk about it in my 2013 book a little bit.
Right. So, did you want to introduce another topic?
Well, I wanted to pick up on a couple of things you said about, you know, how the properties of the kinds are unified, and you said, you know, obviously it's not a good idea to hold a view hostage to the possibility of infinite descent, which is very controversial and maybe implausible. But you know, if that's the case, I do think one would have to end with a sort of brute fact and say, yeah, the properties of the most fundamental kinds might be unified just as a matter of brute fact. You know, and I suppose I sort of I side with Wittgenstein here. You know, justification comes to an end somewhere. And I mean, I guess the problem with the alternative, I'm sort of trying to pin down where our differences lie, is that, you know, you said you're describing what you call the abstract categorical structure of reality. So it's not, you know, it's not really about empirical matters, even though maybe the empirical facts of the matter inform the metaphysical picture. And I guess, you know, I'm not sure how one would go about justifying that is the abstract categorical structure of reality. I mean, one can paint a attractive metaphysical picture, which I think you have painted in the book, and it is based partly, as you say, on E.J. Lowe's metaphysics, which is also a very neat, you know, four category structure. But I guess what I'm puzzled about is how one goes about justifying that kind of a metaphysical picture.
Yeah, good. Thanks. This brings us to the tricky issue of methodology and epistemology in metaphysics, right? Yeah. Well, as you say, I do think that there's information that we can get from the empirical sciences that is, if not directly telling us about the categorical structure of reality, then at least giving us a good idea of what the options are. So in some sense, that's, I think, the best we can do. I don't think that there's going to be any certainty ever about what the true categorical structure of reality is, but we have had a number of options on the table, you know, already from Aristotle and beyond that. And I think that some of those options seem perhaps less likely now in the light of empirical information, but they haven't been ruled out necessarily. So I regard this as an a priori endeavor to study the categorical structure of reality, but it's not a pure a priori endeavor, if you like. It's going to be done in a type of bootstrapping with the information that we get from the science, and that we try our best to verify. So I can give an example of how I think that this can happen from the work of my colleague James Ladyman here at Bristol, who of course defends very controversial view, structural realism. Not so controversial anymore. He's convinced a lot of people, actually. But it is controversial because it eliminates one of those very traditional categories of reality, the category of substance or individual, if you like. And of course, this was for Aristotle seemingly the most important of the categories, or at least in a very important role. And same goes for E.J. Lowe's four-category ontology. Actually, that substance is a key category for this. Now, if what my my colleague James is saying is correct. We should prioritize the relations between entities over the entities themselves, or the individuals, I should say, or the individuals themselves. And of course, there's moderate versions of structural realism that say that the relations and the individuals are on a par. But on the more extreme view, at least Stephen French defends this type of view, we should just eliminate the category of substance. And obviously this is based on information that we get from physics, quantum mechanics in particular. And the challenge then is to understand, well, how would this type of categorical picture work, picture about the categorical structure of reality? And that work, I think we can do, regardless of whether these people are right about the elimination of substance. So we can know what it would take for the categorical structure to be like this, or at least we can attempt to say what it would be like. And it could turn out that there's no coherent way of cashing out that structure. In that case, we probably should reinterpret the information that we get from the sciences and understand it differently. So there are difficult questions that have been raised for people who defend this type of structural realist framework, for instance. This is just one example, obviously, but it's a very striking one, because we have used the notion of substance or individual extensively in metaphysics and in science as well, I should say. So maybe this gives some idea about how I think this process works. It's very much done in parallel and in collaboration with the science. But ultimately, we can only make a sort of educated guess about what the true structure is. What metaphysics, in my view, is essentially about figuring out the different possible combinations that could be compatible with the empirical data that we get, if you like. Does that make sense?
No, I agree with that part. Maybe the part that I disagree with is there any sort of a priori content that's coming in there? Or are we just looking at the deliverances of the sciences and trying to take a step back and derive some kind of more abstract theoretical structure from it, right? And in doing so, do we actually bring to bear any sort of a priori considerations, or are we just looking at coherence and consistency and things like that? I mean, if I understand Ladyman's work in the book Everything Must Go, Ladyman and Ross, I guess, their methodology is much more austere in that I don't think they lean on a priori considerations at all. And in saying that, in supporting structural realism, they regard themselves as positivists, I think, in their methodology, in terms of just sticking sort of close to the empirical evidence. But of course, one has to take a step or two back from the empirical evidence and abstract away and idealize. Now, I guess where the difference between us may be is, in doing so, do we draw on a priori considerations, or are we just looking at these kinds of considerations that I mentioned before? Like consistency.
Yeah, I mean, well, for what it's worth, I think that those considerations are also a priori consistency. but that's I think that's pretty trivial. It's effectively logical content. But you're right in that I would take a different view. Now, I mean, my conception of the a priori is maybe not quite traditional, but I do think that the process is somewhat more subtle than the scientists have done their work here, and now we as physicists or metaphysicists or philosophers interpret that and maybe just check that it's coherent. Now, rather, a lot of the a priori content is already present in the work of the scientists themselves when they interpret the data, when they set up the experiments. you would do things a little differently if you think, well, I mean, it's difficult to give a very concrete example, but if you didn't have presuppositions about the categorical structure of reality, you would be designing different kinds of experiments and looking for different kind of evidence already. So some of the a priori work, despite it being the purview of metaphysics, is done even by the scientists themselves. And of course, then we do have to interpret the data. And when it comes to data from quantum mechanics, for instance, it's a very complicated procedure, and that's where philosophers contribute as well. But so I don't see there to be a kind of a demarcation between science and philosophy in the way that some metaphysicians and some philosophers of science maybe even do as well. But yeah, I do think that the a priori work does come in there in some form or another.
Yeah, I mean, I guess I agree with you that there is always some metaphysical content in the scientific theories themselves, and also that metaphysical content is partly a matter of interpretation. And I guess where I disagree is whether that metaphysical content is a priori, or whether it just involves sort of abstracting away from the actual, scientific theories themselves. But I guess, as you said, it depends on what one's conception of the a priori is, which may be a discussion for another day.
Yeah, that's fair enough. I mean, it depends on your views of what a theory is, what kind of element a theory is.
Right.
So since we are talking about scientific theories, they do not, strictly speaking, concern actuality or purely empirical data either. So a theory or a model, if you like, is already making some sort of or bringing in some sort of modal considerations. So one question is how do we view the relationship between possibility, so the possible combinations of things that a model might describe, and the actual true description of reality, if you like. So I think that there's subtle questions here. And some of this is just getting clear on the notions that we use. But maybe that's a natural place to stop for the day. I think we've covered a lot of ground
on quite a few topics. Yeah, maybe we should have another discussion one day about things like the status of the a priori. Mm-hmm. And things like sort of what the metaphysics, how to understand the metaphysical content of a scientific theory, and so on. But
I look forward to that, and also we should return to this and talk more about natural kinds when your book is finished.
Yeah, absolutely. Yeah, I look forward to that.
Thanks very much.